Good afternoon, and welcome to the CODERHACK 2023. We'll just let the judges sit down, and then let's restart. All right. Okay, what's CODERHACK 2023 all about? So, staying with the theme of AI, which is this year's SFF theme, we did a hackathon, a global hackathon, which had simply 3 problem statements. And we went around the globe and looked for the best talent that could look at it. We got a fairly good response on them. And now today we are going to meet the finalists who have made the cut. So before we get into that, let me just introduce you to the CODERHACK. What was this all about? So CODERHACK went around looking for real business problems in the real world. And the first problem statement was about looking at large LLMS data. How do you process it? How do you make it effective? How do you make sure that a bot, when it's being used, how the data can be processed instantaneously? Now, we had a lot of good reactions over there. And the participants have been able to put in their data, and based on which they were judged in the first round, and now they would come to the second round after that. The second problem statement was again looking at the same data and trying to use lower amount of resources to be able to compute that data. And the third problem was about looking at branch automation. How can you bring in efficiency in a branch where there is a queuing happening, and how do you make sure that the queues are reduced, the waiting time is reduced? And this could be for anything. It could be a banking branch, it could be a retail outlet or anything. So that was the popular statement that people handled. And we have 3 finalists over there from who have taken that up. So I'm going to call those 3 finalists. And before that, I would like to introduce the 3 judges that we have. And thank you, judges, for coming and making time. So we have, I'm sorry, just, okay. So before I go there, let me look at the grand winner. So the winners are going to get an opportunity network. And this is going to be with Monetary Authority of Singapore office team, and they will be podcast, and there will be some SFF to 2024 complimentary tickets. Something great for, for your career, for meeting up the right kind of people. The second place is on networking meeting, again with the FinTech leaders, and complimentary SFF ticket in 2024. So that's what we are looking forward for, and I would wish the participants best of luck. Now, coming to the most important part, who will play a very critical role, are our judges. So we had Gore, who's the Affinidi Lemma Tree CEO. So big clap, whoop for him. Jennifer Zhang, who's the CEO and co-founder for WIZ.AI. And last but not the least, Suresh Shankar, who's the founder and CEO of Crayon Data. And all of them in their respective areas are making waves. And more about them, if you want them to, you can go to their sites and see what they're doing. Now, without any more ado, let me introduce you to the teams. And I'm going to invite the first team, which is Team Rhino. Crescenda, will you please come and take over the stage?
Hello. Okay, hi guys. I'm Cassandra from Rhino Partners. I have my colleague here, Vimukti. We are a software development firm that specializes in FinTech and InsurTech, and we are very excited to share our solution for the hackathon with you guys here today. Most of our team is actually based in Sri Lanka, so the guys who developed this code, they're not here, but we will do our best to take you through this as well as possible. If you see any of my glorious typos, please come by and tell me about that later, and you can redeem a free lunch from me. Thank you. Okay, so firstly, the topic, branch demand forecast and optimization. Oh yes, this is more about our company. The question was, how can we forecast demand and optimize branch load? Vimukti will take you through the problem statement here.
Yeah, hi. We looked at our daily data for 36 variables in 100 branches over 6 months period. So mainly we looked at branch data, teller data, staff allocation data, ATM data, iBanking data, as well as loans data. Then we wanted to find an optimal number of models to work with through the feature-based clustering, like to categorize the data set that we received. So we understood that going through a machine learning process would be ideal. So we went ahead with a machine learning model called K-means clustering. So what we did initially was to prepare the data sets that we received. So we scaled our data to ensure more effective K-means clustering. So as you can see in the graphs, there's not much outliers. That means the data set is more applicable for K-means clustering. And it features scaling ensures all features contribute equally. So after running our model and getting the silhouette score, we understood that the optimal number of clusters that we can gain out of this data set is 6 because we had low inertia and high silhouette score in that. So then we wanted to actually forecast the banking branch data and stuff. So we wanted to do some analysis. So we ran some autocorrelation and partial autocorrelation analysis on the data sets that we received. So we used seasonal decomposition technique to have a better understanding on the data set. So basically, we understood there was like a bit of a seasonal pattern. So we went ahead with model called Sarima. So yeah. Then by using our Sarima model, we split our data set into 3 sections, and we used 2 of the data sets just to train the model and 1 data set to test the model as well. So basically, after running our Sarima model, we used the MAPE value to understand the accuracy of our model. So we found out that like having a low MAP value in our model indicates like a better accuracy in our model as well. So yeah, then we want to find out the recommendations, like what we can recommend the customers with running our models for data sets that we received. So mainly after doing all the specification, clustering and all that, and getting the forecast model as well, we wanted to find out the best parameters that we can use in the data sets that we received to get the forecasting of that particular model. So we did random forest regression as well, and then we got better accuracy levels as well for that. So I believe Cassandra can explain like what are the key features that we found out by to identify to forecast way better with the features that we received. Yeah.
Okay, so the top 5 important features that we identified were actually customer count, KBZ Pay customer count, the number of current and savings accounts, as well as other accounts. And what this means in terms of business is we could use it in various ways. For example, focusing on increasing the customer base with targeted campaigns to attract new customers, encouraging KBZ Pay services and integrations through perhaps promotional campaigns. If a particular branch has more savings accounts, perhaps we could do more marketing or signage there to encourage these customers to use the banking app and thus reducing branch load. Tech stack would be the usual Python, Pandas, Matplotlib, scikit-learn. And in terms of Gen AI, this one is a traditional machine learning. However, there is a lot of potential for Gen AI with enhanced forecasting, real-time decision support, and personalized customer interaction. For example, with chatbots or virtual assistants. And in terms of scale, this is a versatile model that can be adapted to various problems in various industries. It's cost-effective, and most importantly, it does allow for better customer service and retention through resource optimization and also identifying new opportunities for business revenue and growth. Okay, that's all we have, guys. Thank you very much.
So thank you very much. I'd like to call Natalia, who's our second participant. Natalia is Singapore-based, runs a company known as WIZ.AI, and she's going to be presenting her solution.
Thank you very much. It's a pleasure to be here. I'm Natalia. I am a co-founder and CEO of WIZ.AI. And I have a whole team also with me with background in both data science, engineering, product development, as well as finance industry. So we are very happy to be also at this event and also advisors in artificial intelligence as well as building operations and business operations. So we are also tackling this challenge of the problem 3, which was very interesting for us because we started off as a analytics company for buildings, optimizing buildings and looking how can the flow of people and environment be improved. So this was very interesting data set for us to look at. And it's very critical actually because there is many different improvements that can be made by looking at this type of data, including operational efficiency, resource allocation, wait times, reduction, customer service, and cost savings. So as was mentioned previously, we were giving a data set. There is many different variables we looked at. And we also had a chance to apply and optimize our data pipeline. So this is kind of the process that we follow in this challenge is data preparation. So we had to look at the context and build the data models, analyze how we can forecast better based on the variables we were given, and also optimization. So this is another important aspect that we use in terms of making recommendations. So we actually evaluated 3 different approaches and also looked at 4 different types of methods. So the time series method, factor analysis, fuzzy expert, and neural nets. So this allows us to really look at and compare different techniques that could be suitable for this data to make this kind of model work better. It's also important to look at the data itself before we work with it, right? So we explored the data across different patterns in terms of dates and over time, over weeks, and over months, which allows us to get some really interesting insights into this data. And we also compare different types of models that are suitable to making this type of forecast. So we took a very rigorous approach to this data set, so spent quite a lot of time looking at different and benchmarking the performance, and we found that ARMA model was working quite well for us, and it was actually making very good predictions that would be suitable for this type of application between usually 92 to 96%, depending on the specific period we are looking at. However, the neural nets and RF also work quite well, but they do require larger data inputs. So we noticed that with the data which we were given, which was only 6 months, we did not really have enough training data to be able to make this kind of optimized performance. So this was one of the gaps that is in this type of analysis. If we had longer, we could make it work better. So the prediction performance you can see here is the forecast, which is in orange. Y is the actual data from our split between test, validation, and deployment. So the training versus test and deployment. So on the test data, we've seen quite good performance. Forecasts were relative to the actual target, as you can see here. And then we were wondering, how can we integrate it to actually serve the customer better? How can they use this information to plan the branches better? In fact, we are already working with some banking branches, implementing like IoT solution plus other data sources from their operation. And we think this kind of information could actually be very interesting and useful for us to integrate in this type of software. So this hackathon actually gave us a lot of ideas to explore how to further improve some of the existing products we are working on. So looking at the time and space patterns within those branches and identifying trends, anomalies, and alerts. Also benchmarking across time and space and recommending actions that the operators could take to improve things. And finally, root cause analysis. So it's critical to identify why certain things are happening and why certain models, in terms of the different variables that we looked at, why are they important. So this is another thing that we do within our solutions. and intervention testing. So let's say a branch is seeing like very high traffic levels and understanding why this is happening and also what can be done to modify the operation. So this is also something we integrate. So we already had some case studies for similar products looking at operations of retail, hospitality and other sectors, and already working with customers to implement this type of solutions. But this hackathon, I would like to highlight, it was very interesting for us. We learned a lot through this experience. We learned what kind of additional data set can be used to improve our models and how can we drive additional value for our customers. And we really think it's a very scalable solution for us to explore further. So thank you very much for your attention and looking forward to be in touch with you. Thank you.
Thank you, Natalia. Thank you. Thank you for that lovely presentation. Very well done. Judges, do you have any questions to Natalia, please? Any clarifications?
Do you mind actually address a little bit about tech stacks? Because you didn't really address too much in the presentation. Yeah.
The tech stack, right?
Yes.
Yes, so we have several different layers in our tech stack and also within our data pipeline. So on for R&D, we mostly rely on Python and build models in Python and R. This is, preference of the team, and also it's quite powerful in terms of the tools we use. And then for the front end, we rely on a combination of different frameworks. We work a lot with Google products right now in terms of data visualization, just because it's already working quite well, and our team is also likes using this. So yeah.
And you mentioned that the ARMA model gave you 92 to 96%, and neural network didn't work. What happened to the random forest and the other two models?
Yes, great question. So within neural nets, we also, when we were fitting the data, we noticed that it was overfitting because of the limited data set. So I think in our experience with similar types of data set, it's very critical for neural nets to be able to have at least 1 year of data, or at least 8 to 12 months. To give good results. Because of the seasonality of the variation, it's just very limited, and because we only get like basically very limited set of observation per branch. If we had like more detailed observations, then we could make it work better. Within random forest, we also deployed it, so it was having a bit improvement in performance, maybe 3 to 5% improved accuracy, but it was still not as good as the other models. So yeah. So what we noticed with some of these approaches of building predictive model using SVM neural nets, and even in the case of random forest, there is limitation in terms of having to have access to larger volumes of data to show the good performance. In our experience.
What was the, what are the top 5 predictors that you came up with for improving the branch performance? You didn't address that.
Yes, so the top 5 predictors we used includes the cash withdrawals, the number of, so what we wanted to do is we wanted to optimize the performance of the branch versus the number of people to enhance the productivity. So there is several different interested indicators in the data set, including the number of staff serving the customers and also the activities happening at the branch. So we looked at the time and across the branches, and we noticed that the rates of the cash withdrawals, cash deposits, as well as investment activity that was happening in the branch was very important for the branch to give an indication of the branch performance, but also in terms of the predictors of the productivity, we looked at the number of staff. So we combined 10 critical variables that were important in terms of the metrics that we tracked in terms of our model performance. And we used those predictors to be able to deploy in our final model to generate the best results. So we compared about 30 different models, and we use those predictors which show the best results to generate those models.
Thank you. Thank you for those clarifications, Natalia. Thank you for your time. I need to call team number 1 again because we didn't give them an opportunity to ask questions. So would the judges have questions? We just have Rhino team back again.
Yeah,
I do have one. You use k-means. Why did you use k-means?
Yeah, so we used
And second question, why only one method?
So basically, the requirement was to, like, I believe, like, I'll give you the best answer with my knowledge because the development was done in our Sri Lankan team. So basically, the requirement was to identify, like, cluster, like, categorize the data sets that we received based on the data, like, we can gather, right? Like, with whatever the data which we received, we should be able to categorize the data, like, create into clusters. So k-means model, basically, it runs on high dimensions. So in our code, I believe there was like 13 dimensions. So basically, in a 2 dimensions perspective, I would, if I am to explain, like, what it does is, like, let's say you have spread across all the data in the entire dimension, and there would be like data points in each and every area. And what it does is it does like when you run it iteratively, it checks the distance of that particular data point to the other one, and it groups, like, it categorizes into one. So we wanted to run k-means model just to create the clusters. So that is one of the main reasons I went that, and depending on the requirement as well.
Any other questions?
All right. Thank you so much.
All right.
Yeah, thank you.
Thank you. Thank you so much for those. And now, last but not the least, these were teams which participated. Now we get an participant who's an individual contributor. He's worked in the industry, but he comes with his own horsepower here. So welcome to Srinivas Kumar. The stage is yours.
Thank you, Prem. Hey, good afternoon, everyone. Problem statement branch optimization. Okay, so how we approach this problem is first we started with the data, because what goes in whatever model you build, the outcome primarily depends on the data. So we examined the last 180 days of data, and we looked for like null values and even formatting issues, and we corrected that. And then we have done the EDA, univariant analysis, bivariant analysis, and look for outliers. And then we have done the feature engineering. And then this is out, we have done the first step, so data cleansing part. And second, we looked at the data, like we wanted to understand the trend. So we picked up transaction count will be one of the key variable that we need to focus on. And we wanted to see like overall among all divisions. In the data we have like 4 divisions. We wanted to see like, is there any spike on a particular day or in a particular branch or in a particular division? So that's how we taken the approach. And then we noticed in the data we have like a few channels, and there are transactions happening on the branch at the teller side where really a use staff is required to have the face-to-face to support cash withdrawals, cash remittance, and cash deposits and all. And then we have like seen ATM transactions there, and then we have seen online transactions. And we have created, we looked into this, whether these channels have any impact over the transaction volume. We did this. And then finally the last part, the tools part. So we used Excel, we used Python, and we used modular model. Okay, let's go to the next one. So on the data part, like we group them into like anything like channel related, park them under channels like branch tellers, self-assisted channels, online channels. And then we notice few variables that we keep for profiling and all. Because there are certain transactions, some customers always prefer to do face-to-face transactions. Some customers always love to do online transactions. We want to look at that data also. And then on this data, like there are 4 divisions. We look at the overall volume, what is really happening. And we noticed the Yangon branch where the teller transactions are a little high compared to other branches, other divisions. So we wanted to go deep to the Yangon. So among the Yangon, It's not the latest one. Okay. So among the younger branch, sorry. This is not the latest slide. My slides, this is not the latest one. Sorry, this is not the latest one. Sorry for the confusion. Okay. So guys, what I done is I picked up the Yangon division. Within the Yangon division, I identified one branch, and in that branch, I done the like I don't know the slide. Okay, so I done the modeling for that one, and then what I did is I split it like 180 days of data, no, like test and train, and um, sorry. I think in terms of like transaction, the pattern, it looks like that only. So after running the model, like we have seen like the test one I kept for 12 days. So I was able to match that trend. So the trend was like really looking nice. And in terms of recommendations, there are 4 recommendations I wanted to make. One is, so we need to really enhance the digital platforms. So we need to find out wherever like the human interaction is there. We need to migrate it quickly, and then we need to have a digital queuing system. So we need to put it in our apps so that the customer, now before he come into the branch, he will have a view what is really happening, whether the volume is there or not, whether the walk-in customers are more. Then based on that, he make a decision. So he can do, and then we need to run a quarterly campaigns to encourage customers to understand like there are features, there are new features added into our mobile apps. So start using is that. So this way, like once we educate the customers, we need to keep on educating the customers. Like quarterly, every quarter we need to send this one. This is very important one, so that customers know can the stickiness will be like more. And then last one is like we need to evaluate, like monitor and evaluate this whole exercise like every month or every quarterly. Yeah. Thank you guys. Thanks. Any questions, sir?
Hello? The mic on for Suresh? Yep.
Hello. Hey, don't worry about the presentation going off. Shit happens in the world. Just tell us in 1 minute, what are those 2 models you ran and what are the output that you got from them? Forget about the deck.
I picked up one model from the Yangon branch. There are 180 days of data. Okay, and then in terms of when I do the feature engineering, I noticed a few interesting stuff. So on the correlation part, so customers with more products, they tended to do more online transaction. That is one. Second is, it's very, very interesting one. Huh? There are customers who do ATM transactions in the branch, but they have interaction with the branch staffs also. So this is something like very tricky one. I don't know why it is happening. Because ATM, it's meant for self-assisted channel by definition. But on that day, more customers are doing ATM, more customers are doing face-to-face interaction with the staff. So it means some of the ATM, whatever service which is there in the ATM, it requires some additional help. Somebody have to guide the customers. So these are the things. No, I think it's something really, really interesting. We need to really do a deep dive, and then we can do some more stuff there. Yeah, and then savings account holders and customers with branch with more customers. There are tendencies like they always do online transactions.
Why Excel?
Okay, Excel means, okay, the first step, I think, before jump into any model, I wanted to see what is there. I want to visualize the data. So simply done a pivot table on day 1. Looked at how many divisions are there. There are 4 divisions. And then within each divisions, there are 4 territories. And then there are 100 branches there. And then 180 it is. This level of information, before go into Python and all, I wanted to see myself through Excel. Just looked in. And then one thing I noticed on the date field, I don't think, purposely someone inserted some data. So the data is not at all clean at all. So even though it looks late, I tried many functions within Excel to convert the date, and then I finally done it. This I would have done only through Excel only. So if I started with Python, Python is a more sophisticated tool, but Excel has a lot of features the visualization one that really helped actually to understand the data better very quickly without thinking about any model and all. And after looking at this data, then finally I decided let's go with Arima model. Okay, I did XGB boost regressor, but I didn't happy with that. Finally, the last part I just simply taken the days and transaction count, and then I proceeded with the Arima model. And then the 180 days I just split train and test. I put 12. I kept it for test. So the projection of the trend was really I was able to match most of the days. Not 100%, most of the days I was able to match. So the transaction in a few days, I think I remember 19th June, it shown 78 something. I was predicting to 76 something like that. Yeah. And the only problematic part we need to look at the profiling. I don't have the enough data. So profiling, I think we need to have more data, because not all customers really allowed to do online transaction. We need to really profile them. Even when we talk about marketing campaigns, educating digital stuff, not everybody will really love it actually. There are some customers, they really need some physical attention. So we shouldn't target them unnecessarily. So we need to profile them, and then based on that, I think bank really can have a better interaction with the customers, and customers also will listen to us. Otherwise, all our communications will go wasted.
Okay. Thank you, Srinivas.
Thank you.
Thank you very much. Thank you, judges, for all those probing questions. Give us a few minutes to compile the results, and we'll be back in a few moments. Thank you. Hello, I'm back. So thank you very much for the patience of waiting. That was a very, 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 very close competition. And the judges deliberated. They looked at all the entries which have come in, looked at the tools that are being used, what is conventional tools, what are the latest tools, and then a very close decision has been made. And I'm going to invite Mr. Yong Leong from Alevandi, who's going to read out the results. So hold your breath here. A very, very close competition.
We just wanted to say that just to the teams, thank you very much for the thing. And we actually found that 3 teams did something all very differently. The first one was very comprehensive in terms of the way they approached the problem. The second one, the visualization and the storytelling, was a very strong point. And the third one, I know in spite of the fact that you had the wrong thing, had a really great explanation, and we were actually taken up by the fact that you started with Excel and Python. We actually say, hey, that's a lovely practical way to do it. And I just want to make another comment, especially to the gentleman. Don't worry if things go wrong. This is how startups are. And you did a good recovery when you came back and answered the question. So, that's basically the feedback for the teams.
All yours.
Okay, so are we ready to have the results? Can we have a drum roll, please? Actually, before that, we should invite Umang, CEO of APIX, to stand by to give out the prizes. Just testing you guys, warming up. So now can we have the actual drum roll? All right, in third place, we have Rhino. Take a photo. Thank you. All right, our first runner-up, drum roll again, please. We have Iyer. All right, for photo time. Thank you. And I guess we don't really need to announce the grand winner anymore, but the grand winner is Srinivasan. He bounced back from the setback to clinch the grand champion title. All right, thank you.
Stay on. So
All
can we
teamed up
have all
for
the
group photo?
judges, please? Thank you. Thank you, all the audience who supported this. And thank you, judges, for making time. And last but not the least, thank you, participants, for being here. All the three teams, great work.